Okay, so we've created a function and we now understand the trapezium rule. So we want to now create a function to implement the trapezium rule. This is step 3. Create another MATLAB function to implement the trapezium rule to integrate this function between specified limits. If we jump back here to part 2, it tells us to read section 14.2, page 300 from the ebook, Essential MATLAB for Engineers and Scientists on Novel. So I'll just show you quickly how to find that book on Novel. If we go to Portal, we can click on Library Search and then type in Novel. Then the first link, okay, we can click on Novel. And now we can search in Novel. So I can put in here Essential MATLAB. Make sure I spell it right. And see what that gives me. Looked like it came up there. Yeah, Essential MATLAB for Engineers and Scientists, 6th edition. So I can click on that. And then I need to get to page 300. I think, yeah, it's in chapter 14. We're looking at numerical methods. The trapezium rule is a numerical method. And if I go down to page 300, it talks about integration, the trapezoidal rule, the trapezium rule, and it gives me some code. So I did this because I'm lazy. I don't want to type the code out from the sheet. I just want to do cut and paste. So if I copy that, I'm hoping that I can just paste that into MATLAB, maybe tidy it up a bit. So I need to open up, click on this tab to open up a new script. Then I'll paste that code in. Okay, didn't work. Let's see if I can do it again. Actually, it may not work this. I may have to actually copy it in. If I go back to the book, yeah, I guess it's not letting me copy this. Oh, maybe. Let's see if now this pastes. Yeah, great. Okay, so I could paste that code in. Okay, so let's just explain what this function is doing. Well, first of all, let's save it. So when we save it, remember, the default will be that it'll save it in a file name equal to the function name, which in this case is trap, short for trapezium. So I'll do that. I'll just hit save, and it's saving it as an M file of the name trap. And now I can run this function. But let's look at this function first. It takes in these input arguments. Remember the things in the brackets are the input arguments. A is the lower limit of integration. B is the upper limit of integration. H is the trapezium width. So A, B, and H are just all normal numbers. Then the first input argument here, Fn, that is actually a pointer to a function. So you can pass this code any function, and it will find the area under that function between x equals a and x equals b with a trapezium width of h. The first part of the code calculates the number of intervals, and then the next bit of the code sets up a vector corresponding to the intervals of each trapezium, and then implements the trapezium rule to calculate the area. Rather than explaining this now, what I'm going to do is actually call this function and then use the debugger to step through it and show what the function is doing. So if you remember the debugger, I can actually click anywhere in a function, and when MATLAB runs, it will stop at this red point. Okay. So what I'm going to do, I'm actually going to call this function, and I'm going to pass it the function that we've just set up earlier, which is this function. Okay, so let me now do that.